All right, so the next concept we're going to look at is basically quantifying solubility. How much of a solute can I actually dissolve into water before water says, whoa, this is way too much. I can't take any more dissolving. Now, every substance has a numeric solubility, so an amount that can be dissolved in water to the point where it becomes what's called saturated. We have a saturated solution has as much solute dissolved into it as it possibly can have. So it's basically how much can fit into the solvent. But solubility actually changes at different temperatures. And for most substances, that means at higher temperatures, you can dissolve more solute into water. The reason for that is because the water molecules at a hotter temperature can move faster. They're a little bit more free fitting as far as surrounding the poles and positive and negative charges. But that's not true of every solute. There are many solutes that actually become less soluble at hotter temperatures. So it's not a hard and fast rule. So you always want to, check the internet. I'm going to post up a chart right here. So this one is from the notes, and it's the chart that I use when we're doing tests and stuff for these questions. So any questions I ask you in quizzes or whatever in the future, I'll always be using this chart if we do a question like this. And you can use a chart to basically figure out what the solubility of a substance is at a temperature, and there's lots of different substances on there. So you just have to use the old interpolation. Is it interpolation? Interlopation? Interpolation. Okay. So using the chart, you can interpolate values by, if I give you, the temperature, you can use that to trace up to the line that you have to get to. You can, I'm not, if I'm giving you a chart like this, I'm never expecting you to come up with an exact value. You know, estimated, as long as it's reasonable and you followed the steps in the right way for the number that you found, you're going to be good. So just give it your best estimation. But you can trace up from the temperature I give you to the line that you have to get to, and then trace to the left to figure out what the solubility of that substance is at that temperature. Now, the chart that is right there is for 100 grams of water. So it's how much solute of whichever identity that you have to look at is going to be able to dissolve into 100 grams of water, or about 100 milliliters, right? About a fifth of a bottle of water. Um, and but obviously, you're not always going to use exactly 100 grams of water. Sometimes when you're in the lab, you're going to use different values like 400 grams or 5 grams. So what you need to be able to do is interpolate information from the chart there and adjust it based on the amount that's there. We're going to look at hydrochloric acid. You can see the HCl line there is one of the ones that actually goes down, which means it gets less soluble at higher temperatures. Now it's asking to know what the solubility is 400 grams at 50 degrees Celsius. So if we find 50 degrees Celsius at the bottom, trace it up to the HCl line, and then we can pull it to the left, and it looks like we've got, I'm going to say about 58 grams per 100 grams of water, which is exactly what I was trying to find. So my answer right there is the solubility is going to be 58 grams is how much we can dissolve into that. Now, the next one, as you can see, it's 400 grams. So we have to do a little bit of math on this one. We're going to look this time at potassium nitrate, or KNO3. You can see it on the graph there. And this one is quite soluble at high temperatures. You can see that the temperature actually really affects how soluble this is. At room temperature, it's about 40 grams, but you raise it to 70 or 80 degrees, and suddenly you can put 3 to 4 times as much solute into the water. Now, here we've got 10 degrees Celsius, so we'll start at 10 at the bottom, and we'll trace it up to the KNO3 line. right there. And then to the left, and I think we've got about 24 grams there based on my estimation per 100 grams of water. But I want to know what it is per 400 grams of water, not per 100 grams. So I know that to get to that, I got to multiply by 4. And it makes sense. If I've got 4 times the water, that means I have 4 times the solubility. And in fact, I do. So you're going to end up with 96 grams being the solubility of potassium nitrate in 400 grams of water, or a little bit less than a water bottle. Okay. The next one we're going to look at is potassium chlorate, KClO3. We're going to look at this one at 90 degrees Celsius, and we're going to do 5 grams of water this time, so we have to do a division instead of a multiplication. Let's see, there's KClO3. We're going to 90 degrees Celsius, so that's near the end of the table. So we'll track that up to the line that we want, and then we'll track it to the left. And it looks like we've got 52 grams dissolvable per 100 grams of water. But I want to know what it is per 5 grams of water. So that's a move of dividing by 20. We have only a 20th of what the table tells us, so we got to divide by 20 there. We'll divide 52 by 20, and I'll see if I can do my math skills. Okay, I think that's 2.6 grams. Yep, okay, great. So solubility here is 2.6 grams. Not too much. Not too much. But again, talking about 5 grams of water, or half a mouthful. So if you think about it, that's really quite a bit. And if you look at those really high numbers on the table, think about what the lines that go above 100 grams mean. That basically means that at certain temperatures, compounds like potassium nitrate can dissolve more than 100 grams into 100 grams of water. So you can actually dissolve more solute than there was solvent to start with, which is something that many ionic, the property that a lot of ionic compounds have, for sure. Okay, the last question's a little bit different. You have to think a little bit about this one, but it shouldn't be too bad. This one we have a situation where I take 100 grams of water and I saturate it with NH3, which is ammonia. And this is at 10 degrees Celsius. Then what I do is I heat the water to 90 degrees, and I want to know how much of the ammonia is going to come out of the water or dissolve out of the water as it heats up to a higher temperature. Now, if you look at the curve there for ammonia, you'll see that it is one of the ones that actually gets less soluble as you heat it up. So if we saturate it at a high temperature and then heat it up to a point where the water can't hold that many grams, what'll end up happening is you'll have some of the solute come out of the solution. If it's a salt, it'll usually come out as a precipitate, which is a solid chunk. So more like salt crystals will reform in your water. Ammonia, when you put in water, actually, when you dissolve it, starts a chemical reaction and creates a base made of ammonium cations and then OH minuses, which is... So what we have to do for this question is figure out how many grams of ammonia I dissolved in the water when I started, and then how many grams of ammonia can stay in the water when the heating is done. So if I look at 10 degrees there and I track it up to the ammonia line, it looks like at 10 degrees, the solubility of ammonia is about 70 grams per 100 grams of water. Now you'll notice that I left this as 100 grams here just so we didn't have to do that dividing thing, but it'd be something you could do in a question like this as well. Then we heat the ammonia up to 90 degrees. So we'll look at the 90 degrees, track that up, and we'll find that at 90 degrees, we only have a solubility of about 10 grams per 100 grams of water. So basically I got to subtract these. because the 60 grams, that 60 of the 70 grams that I dissolved in when I started can't stay in the water once the temperature gets to this point. So 60 grams of ammonia basically come out of the solution and leave the water as it heats up. That's it for this lesson. There's no quiz this week. We'll get back into them next week. For now, spend some time starting on your My Pet Element project, which is posted. Don't forget, you got lots of time to complete that. It's not going to be due until 3 weeks. I think that's the first Friday in June. It's not due until Friday, June 5th. So you have lots of time to work on that slowly at your own pace. If you have any questions about it, drop me an email. I'd be glad to help. You can send me pictures of things. I can give you feedback, whatever you like. But for now, enjoy, and hopefully you had a great long weekend. See you next time.